Hello everybody. Today we are going to study nuclear physics radioactivity lecture 3. Let's talk about first what is artificial radioactivity. So in the earlier lecture we talked about natural radioactivity where heavy elements they emit alpha beta gamma rays on its own. But when we talk about artificial radioactivity here basically it is emission of radiation from elements much lighter than those occurring in nature by modern technique of artificial transmutation. So here in case of light elements we can induce radioactivity, so that is artificial radioactivity. So let's take the example in Rutherford's experiment. Nitrogen nucleus, when it is bombarded by an alpha particle, we get fluorine. So here nitrogen and helium, they are combining together to form a single nucleus. So that particular nucleus, it is called as compound nucleus. So remember that when two nuclei combine together to form a single nucleus, then that is called as compound nucleus. So here fluorine is a compound nucleus which is formed, and it is not stable, it is unstable, so it will disintegrate to give oxygen and proton. So this is the kind of artificial radioactivity reaction. Now let's talk about radioactive decay. So we have three types of decay. One is alpha decay, beta decay, gamma decay. Now when we talk about alpha decay, when a radioactive parent nucleus it emits an alpha particle, it results into a daughter nucleus. In case of alpha decay, the atomic mass number of the daughter element will reduce by 4 units and charge will reduce by 2 units. So this is very important. So you have to remember, whenever an alpha particle is emitted, charge reduces by 2 units, mass reduces by 4 units. When we talk about beta decay, we know that beta particles, they are nothing but electrons. So when a daughter element will be formed, mass will remain same as electrons do not have mass. So mass will remain same, but charge increases by 1 unit. And when we talk about gamma decay, so gamma rays, they are electromagnetic radiations. So when a radioactive element disintegrates by the emission of gamma ray photon, there is no change in atomic mass number or charge, as they are the radiation. So when this so basically a nucleus, it is in excited state. The excited nucleus, it comes to the ground state by emitting gamma rays. That is it. Now today we are going to talk about properties of alpha particles. So alpha particles, as we have already discussed so many times, they are nothing but helium nucleus. Charge is positive on alpha particles and the magnitude of that, it is 3.32 into 10 raised to minus 19 coulomb. Or simply, if you cannot remember this value, just whatever masses of elementary particles we take in terms of mass of electron. So you know that mass of electron, it is 1.6 into 10 raised to minus 19 coulomb, and charge of alpha particle, it is 2. So mass of alpha particle, it will charge of alpha particle, it will be 2 times E. So 2 multiplied by 1.6 into 10 raised to minus 19 coulomb. So whatever that calculation will be, that you will get. And mass of alpha particle, it is 6.6 into 10 raised to minus 27 kg. This mass also you can remember as 4 times mass of proton. Mass of one proton, it is 1.67 into 10 raised to minus 27. 4 times of that. So you will get this 6.6 into 10 raised to minus 27 kg. Even if you don't remember these values, you have to keep in mind, think about it, what is the mass, what is the charge. Then simply by doing, once you know mass of proton, you can calculate mass of helium alpha particle, and once you know the charge on electron or proton, you can calculate the charge of alpha particle. So that is easy. uh, Next point is they get deflected by electric and magnetic field because they are positively charged. As they possess charge, they get deflected by electric and magnetic field. They have least penetrating power, but they have highest ionizing power. Second, properties of beta particles. Beta particles are nothing but they are fast moving electrons. Charge of beta particle, it is negative. Magnitude is 1.6 into 10 raised to minus 19 coulomb, and mass is 9.1 into 10 raised to minus 31 kg. Now as they are negatively charged, they get deflected by electric and magnetic fields. Their penetration power, it is around 100 times more than alpha particles, but they have less ionizing power as we compare them with the alpha particles. Third, properties of gamma rays. So gamma rays are basically electromagnetic waves, or you can call them as photons. They have no charge, zero mass, and they do not get deflected by electric and magnetic fields, as they do not possess any charge, so they do not get deflected. But when we talk about penetration power of gamma rays, it is about 1,000 times that of alpha rays. And ionizing power, it is least, as so alpha particle has the highest ionizing power, but gamma rays, they have the least ionizing power, but penetration power is the maximum. Now, a very important law in nuclear physics, that is law of radioactive disintegration. So it says that rate of disintegration of a radioactive substance at any instant is directly proportional to the number of atoms present at that instant. And this law, it is also known as statistical law of radioactivity. So this law is very important from the derivation point of view. There are so many numericals based on these laws, and when you go for competitive exam also, this particular formula, it is very important, so you have to understand it properly. Suppose n be the number of radioactive atoms present in a particular element at a given instant time t. If dn is number of atoms which gets disintegrated in a small time dt, then we know that rate of disintegration, it is given by dn upon dt, and that rate of disintegration, it is proportional to n. Okay, so dn by dt, it is equals to minus lambda n, where lambda, it is the constant of proportionality, and here it is called as radioactive constant or decay constant. And here minus sign, it represents that as with the time the number of atoms are disintegrating, so number of atoms will reduce naturally, so that is why here minus sign is there. So now it depends on the nature of the substance. Negative sign indicates that the number of atoms of radioactive element decreases with time. Suppose we rearrange this term, simply I have rearranged. So dn upon n equals to minus lambda dt. Then I will integrate both sides. So I will get integration of dn by n is equals to integration of, here there should be integration of minus lambda dt. So integration of dx by x, it is log x to the base e. So here log n to the base e minus lambda t plus constant of integration k. Whenever we get equation, most of the derivations are similar of this sort only. So we are getting constant of integration. So next step will be to find out the constant of integration. So for that we will substitute initial condition. So n equals to n0. That is the maximum number of atoms present originally at time t equals to 0. So initially, when t equals to 0, we have maximum number of atoms. Suppose n0. So t equals to 0, n equals to n0. When we will substitute in this equation, we will get k equals to log n0, because log of n will be replaced by n0 and t is 0. So this lambda t will come equals to 0. So we will get k equals to log of n0. Now we will substitute this k equals to log n0 again in this equation. So we will get log n equals to minus lambda t plus log n0. I will shift log terms to on one side. So I will get log of n minus log of n0, log a minus log b, that is log a by b. So I will use that formula. So I will get log of n upon n0 equals to minus lambda t. So finally, taking antilog of both sides, I will get n equals to n by n0 equals to e raised to minus lambda t, or you can shift that n0 to other side and you will get n equals to n0 e raised to minus lambda t. This formula, it is very important. Always remember this formula. This equation indicates that the number of atoms of a given radioactive substance decreases exponentially with time, and this has been verified experimentally. Thank you.